All right, good morning, everyone, and welcome to our Solutions to Help Control Legionella webinar. My name is Greg Jackman. I'm the Specification Program Specialist here at Watts. I'm also the host of this Watts Works Engineer webinar series. So today's webinar is the next installment in this series of webinars geared specifically for you guys, our engineer, architect, and specifier customers. Janet, can you click to the next slide? Just to give you a little bit of a background on this webinar series, we hold several sessions throughout the year that cover a variety of topics. Our presenters are always our in-house technology and product experts, and thanks to our partnership with ASPE, we're able to provide you with the 0.1 ASPE CU credit if you stick around for the entire webinar. This credit will be emailed to you in the next few days if you do so. So next slide, Jana. So after today, our next webinar will be on November 19th. It's entitled Evolution of Mixing Valves and Hot Water Safety. We sent out the invite yesterday for it, but if you didn't receive it, I also just sent a link to the registration page in the chat here. If you'd like to sign up, you can just click on that. We'd also, love to hear from you guys on any sort of topics that you would like to see us cover in this webinar series. We're always open to suggestions. We want to keep this series all about you, focused on your needs. So always feel free to drop me an email. You can see on the screen there, gregory.jackman@wattsware.com, with any thoughts or suggestions or improvements that you think we can make as well. Next slide. So for the discussion today, you guys will be muted, but we do want to keep it as interactive as possible. So if you'd like to ask a question verbally, feel free to raise your hand in the WebEx. You just need to click on the participants button at the bottom right hand of the WebEx, and underneath the attendee menu, you'll see the hand icon, and you can raise your hand and I'll unmute your line. Next slide. Or if you just want to type in a question and use our chat feature to take advantage of that function, you can just do that instead. You just click the chat icon at the bottom of the WebEx, bottom right hand of the WebEx, and type in your question there, and then we'll get to all those questions after the presentation today. Next slide. So with all that housekeeping stuff being said, I'd like to introduce you to the panelists of today's webinar, Jana Sumi, our Healthcare Vertical Market Manager at Watts. So Jana has addressed numerous engineering and architectural design and plumbing industry groups on the multi-barrier approach to mitigating Legionella in on-premise plumbing systems from point of source to tap. Her insight and expertise are based on nearly 20 years of experience in the MEP design and architectural design industries, where she has most recently focused on how commercial and institutional facilities can reduce the risk of Legionella by implementing best practices and proven solutions. So with all that said, let me pass it off to Jana to get started.
Good morning, everyone, and thank you for joining us today. We're going to jump right in here and get started. We do have several objectives for today. They include identifying and recognizing certain conditions that contribute to the growth of Legionella. We'll investigate the importance of a water management program as identified in ASHRAE 188. We'll look at some of the solutions that are available and currently being used in the industry. We'll look at those solutions and investigate some of the pros and cons of each. And overall, we're going to achieve a solid foundation of the current requirements and solutions for Legionella mitigation. So this presentation, as I said, is going to look into some of the solutions to control outbreaks in the building systems, in the building water systems of potentially deadly Legionnaire's disease, which is caused by Legionella bacteria. Today's presentation is broken down into 7 different categories. We'll start with a brief overview, then we'll look at heating, we'll look at chlorination and hyperchlorination, we'll look at copper-silver ionization, UV treatment, we'll touch base on some other solutions, and then we'll also touch base on a very hot topic going on right now, and that's the reopening of buildings after they've been closed for a while. And then we'll talk about some conclusions. So we're going to jump right into a brief overview of Legionella. So outbreaks of Legionella bacteria are caused by Legionnaire's disease, or can cause Legionnaire's disease, I should say, in any setting, but it's a particularly bigger concern in healthcare facilities such as hospitals, nursing homes, and long-term care. Also in hospitality buildings, such as hotels, and really any larger building. And that's because larger buildings tend to have a more complex premise plumbing system. They might have been renovated over the years, et cetera. And then also going back to healthcare facilities, the other reason that healthcare facilities is a great concern is because people who are in those facilities are already immunocompromised, most likely. So if they were to catch, get Legionnaire's disease, their outcomes are usually not as good as someone with a good immune system. So it's interesting to see, but statistics show that there's actually more cases of Legionnaire's disease stemming from hospitality buildings. But because of what I just said, there are actually more deaths caused by Legionella that occur in healthcare facilities. It's important to point out right now that the Legionella bacteria, it can be widespread or it can be in one part of the system. It really can show up in a lot of different ways. Anywhere that there's water is basically a potential area, such as tanks, piping, fixtures, water features, etc. Legionella is a little different from other waterborne pathogens because you cannot get Legionnaire's disease from drinking water. You actually have to basically breathe the water in order to do that. So the bacteria needs to be part of a water droplet that it becomes airborne, and you get it from an aerosol generation. So what happens if someone does breathe that in is that the infected moisture reaches into the person's nose or mouth where it's inhaled, but it settles into the lungs, and that then can sicken the person. Again, as a building or as an engineer, you should be really looking at your water systems when you design them, particularly shower heads, cooling towers, if you have hot tubs or maybe rehabilitation pools, HVAC units, decorative fountains should be considered, and also ice machines is very important to be a part of your design plan and system for a water management plan. And again, those healthcare and hospitality buildings or any building that has a more complex system tends to be, might have a greater chance of having Legionella within the system. But again, they can happen anywhere. So when considering the impact of Legionella, the CDC has given some information as far as who is more likely at risk. And primarily, people who are at least 50 years or older, if you're a smoker, if you have underlying medical conditions, or if for any reason you're immune compromised, you have a greater risk of getting Legionnaire's disease if you are exposed to Legionella. One of the things to point out is you see some stats on this page, and you can see that between 2000 and 2014, the CDC reported a 400% increase in infections, and that's a huge increase. The really important thing to remember, and that's not specifically spelled out on the screen, is that the numbers that we have that have been reported are probably very, very low compared to the number of actual cases of Legionnaire's. There's a couple of reasons for that. And that's because when a person gets Legionnaire's disease, they're presented with a form of pneumonia, and those are the symptoms that they get. So let's say someone gets Legionnaire's disease, they're at home, maybe they recover very easily, they just think it's the flu or pneumonia, and don't realize that it's actually Legionnaire's that they have. And again, let's say the other scenario, they get Legionnaire's, it is very serious, they end up going to the hospital. They still wouldn't know that it's Legionnaire's unless the hospital specifically tests for Legionnaire's. So the lack of testing probably presents us with much lower numbers than we would than are actually out there. Also there on that page is the cost to treat one patient. That's an average, $34,000. That's actually very low as well. It can be very expensive to treat Legionella, both for the patient and more so for the hospital or the place where Legionnaires was contracted. So some things have been put into place to help control or reduce the risk for Legionella. ASHRAE Standard 188 is probably the most known standard. It's a great overview. It gives a lot of guidelines, and it's the basis of what's happened as the industry has suggested or recommended water management programs. So most facilities, when they write a water management program, they look to ASHRAE Standard 188 as a guideline for that. It's recognized by federal agencies and funding sources. And probably the biggest thing that happened in the industry to really implement the use of a water management program was the CMS mandate, or the Centers for Medicaid and Medicare department. So back in 2017, they set an initial mandate, basically to all healthcare facilities, saying they must have a water management program in place to help reduce the risk of Legionella in their systems. And this was really the first time that a mandate was put out that has consequences. So if a hospital does not have that program in place and the CMS finds out about it, if they don't rectify that, they actually risk the possibility of CMS coming in and taking away their Medicaid and Medicare reimbursements. So that's a pretty high risk that a healthcare facility has to take. And I do know that they do go in and inspect buildings and ask for that program. So a little bit more about what that water management program should include. So a full water management program under ASHRAE 188, it's based on a 7-step process. It includes defining your program team, who's going to be on it. You have to survey and document your water systems. What does that look like right now from point of entry to point of use? You're really kind of mapping out that system. You're going to need to analyze your water systems, determine control measures. So basically what that means is we're going to look at our water management system so many times, and we're going to look to see maybe how water temperature is changing, how chemicals that we're putting in the water, those levels. We could be testing for Legionella itself, but we have to define what we're testing and when we're testing. And then we have to set parameters. So when those tests come back, if we fall out of the parameters that the team has accepted, what are our actions going to be to rectify that? So we map the system, we set standards, we should be testing the standards at a predetermined way and schedule, and then identify what we're going to do about it if when we're testing and monitoring, if those results come back and they're out of the decided parameters. The other important part of this plan is that it shouldn't just be a plan that you write and you sit on a shelf. It should be a living document. It should be something that your team is looking at and adapting and changing as needed. The other really important thing I want to say about the water management plan, as proposed by ASHRAE 188 and the CMS mandate, is that there isn't anything in those guidelines that say this is how you must test, this is what you must monitor, this is the schedule that you have to use. You do not see that. Simply what they state is that you need to have a water management plan. In that water management plan, you need to say what you're going to do, how you're going to do it, and what you're going to do if anything is amiss. But those things are completely left up to your water management team. So your water management team decides how you're going to work that plan, and then you must follow the plan. So the team is really it should be based up of several different people that have expertise. So that would include your, most likely an infection control person. a facility manager, maybe your director of engineering, someone within your facility that has the ability to make decisions on spending. And then sometimes even companies or hospitals, hotels, et cetera, might even bring in an outside consultant. That could be a testing organization or another vendor that you might use, or a water quality management firm. So, but you need to have people from all of those different aspects to really have the most effective management team. And again, from an infection control side, your facility side, and your management side. And it's that team's responsibility to create that plan, monitor that plan, and update it as needed. So this just kind of goes into a little bit more about what we've been talking about. So that water management team has to have the ability to monitor and document the program. They have to have the ability to confirm the program performance. So again, are things in the parameters that we've set? We need to be able to communicate about the program. They have to be able to oversee the program. It's important to have knowledge of the water systems within that team, identifying those control locations and control limits, and the ability to take corrective actions. That's one of the biggest concerns right there. So assuming that a hospital or other facility, they're following the guidelines of ASHRAE 188, they have their water management plan in place, so what do they do now? Well, another thing that those two documents do not say is how to actually treat or reduce the risk of Legionella mitigation. So what solutions should you be putting in there to help do that? There's no guideline or code really outlining, these are the solutions you should use and this is why. There are many solutions out there. So we're going to take a look at a few of them today and really look at the pros and cons of each of those solutions. And kind of to expand a little bit about what I'm talking about right here, there is no one solution that a organization should feel comfortable saying, okay, I've got this one solution and it's going to take care of my Legionella issues. Each solution has pros and cons, and each organization or building really needs to look and examine the aspects of their building and then determine what combination of solutions make the most sense for that building. And at Watts, we really preach that you should have a multi-barrier approach from point of entry to point of use. That's the best way that you're going to most effectively reduce the risk. So things that those facilities should be looking at as far as determining what type of solutions they should have are the age of the piping materials, the design of the premise plumbing system. How complicated is it? Is your water continually circulating? At what temperature does your water circulate at? What's the history of that building? Have there been a lot of renovations or additions? Do you know if you have dead legs in that system? And obviously the budget is a big concern about how you choose those solutions. And again, you need to look at the entire system from point of entry to point of use. You can't assume that if you have solutions put in at point of entry, that that's going to take care of your entire system. Same being said at point of use. They really go together, and you need to look at the entire system and how those solutions affect the entire system. So dead legs. I bring this up and I point it out specifically because in my many discussions with infection control professionals and engineering professionals on the facility management side, if you ask them what keeps them up at night as concerning Legionella risk mitigation, most of them will say dead legs. And dead legs are just usually in the system somewhere. They might have been intended or they might have been unintended. But basically a dead leg is where your water is not circulating. It's a section of your pipe that is closed off and there's not enough water circulation. What happens is that water tends to sit there and it's not moving. And so anytime that you have water that is sitting or the flow is too low, It causes an environment in which biofilm can grow and thus Legionella can grow. And it can be very hard to remediate those dead legs once they're in the system. So that's just one thing, one aspect of that design to really keep in mind as you go about choosing different solutions for your building. So the first solution that we're going to take a closer look at is the temperature of your water. It's very well documented how temperature affects Legionella growth. Facilities should, really any facility should include the temperature of that water as part of their water management plan. So a few important numbers to remember. The normal temperature range for Legionella bacteria to grow is generally between 68 and 122 degrees. So below 68, Legionella becomes dormant. And then at elevated temperatures, it will die. And the higher you go up in temperature, the quicker it will die. And that's what that chart really shows there. So you can see at above 122, Legionella survive, but they stop multiplying. Then when you get up to 131, they die in 5 to 6 hours. You keep going up to 140, you get down to 32 minutes. 158, you go down to 2 minutes. And then all the way up to 158 for what's considered a super flush or a superheat, and we'll talk about that in a minute. But those are important numbers to keep in mind as far as water temperature. Again, this is just repeating kind of what I just said. Above 131, Legionella starts to die. ASHRAE recommends 140 as a baseline, and then again, a rapid kill starts at 160. Really, the only time a rapid kill would be considered by a facility is if you do know that you have an issue, you've had a breakout of Legionella, and maybe, especially if you don't know where that breakout's coming from, one of the first things that you can do is heat up that water to kill the bacteria. That's something that you have to take careful consideration of. And how you do that, you have to make sure that your patrons, your visitors, your patients are safe and not exposed to that hot water. But it is one thing that you can do, especially in emergency situations. And touching on kind of what I just said there, it's important when you're looking at water temperature to remember that you have to address the risk of scalding. And unfortunately, the temperature at which water is usually at within a facility when it comes in contact with a person is usually in that kind of party zone for Legionella to grow. And so in order to get it out of that zone and to slow down the growth or to stop the growth, you have to heat it up to a temperature that would provide an opportunity for a person to get scalded. So you have to take a look at that and make sure that everything within your system is going to take care of that risk. And just to let you know, so any water that is above 106 degrees has the potential to cause scalding and pain in humans, while any water above 140 degrees can cause third-degree burns in a matter of seconds. So most plumbing codes limit the maximum temperature exiting a fixture at 120. That might vary between states, et cetera, but that's kind of in general what you're looking at. So what you have to do is look at a solution of really competing sets of interest to find and to probably use tempering valves or mixing valves in order to blend that hot water so it gets up to the temperature that can kill the Legionella, but when it gets to the person, it's gone down in temperature, so it reduces that risk of scalding. So it's really a balancing act that a facility has to take. There's a couple different types of mixing valves out there. Point of source mixing valves, those are systems that you would see located close to your source of your water heater source. And then you have point of use systems that are exactly what they say. They're located at point of use, so at your sink, at your faucet, etc. And both types of those are very common. They have a range of standards that are issued by ASSE that you would need to look into to make sure that you're following. Again, point of use, like we just said, that would be examples of those, again, near those plumbing fixtures, showers, laboratories, whirlpools, all your emergency fixtures, especially within a hospital, you have to consider that. And again, you need to refer to ASSE to make sure that you're following those codes. Really, we've been talking more about mechanical valves, mechanical mixing valves, and you should look at your option of computerized digital mixing systems as well. They give a couple advantages to you. They're considered to be smarter and safer in delivering mixed water throughout the entire facility. Most of these, what you're going to find is that you're going to have closer control over your water temperature. They generally achieve plus or minus 2 degrees within your set temperature. So that's really the most control that you can gain out of any type of system that is used right now, which is very important when you're looking at how temperature can increase or decrease your risk of Legionella. The other thing that, that's important about a digital mixing system is that it can record some of the information that you're doing. It can record those temperature readings and fluctuations in temperature. And that data, what you should be doing with it is implementing it into that water management program. So you can show, hey, we're monitoring our system for our water temperature. And if it does get out of whack, here's what we're doing about it. So again, it goes back to that water management plan as far as documenting and making sure that that's a live working document. There we go. Sorry about that. My button wasn't working. So this is just another look at what a digital mixing system can look like. We also mentioned a few minutes ago that the ability to superheat or super flush the water system. So another way that that's stated in the industry is a sanitizing option or a sanitation mode. And again, that is where you can increase that water temperature quickly to kill Legionella, usually again in a time of emergency. But that digital mixing system makes it a little bit easier to implement that sanitation mode when needed. So heating of water has both pros and cons. One thing, and probably the most important thing about water temperature for Legionella is you know exactly how Legionella grows or doesn't grow according to temperature. It's very well scientifically documented throughout the industry. So you know it's a solution that you can implement into your system. It should be something that, you should be monitoring that water temperature anyways. But it's not going to be the only solution that you should have. There are cons. So you kill all this Legionella by heating up the water temperature, but afterwards that Legionella can regrow. It doesn't necessarily address dead legs. You have to make sure that you're protecting people from scalding. It doesn't do a good job of penetrating slime or biofilm. And so basically kind of what that does, and you'll see this in other solutions, is if your solutions are not effectively entering that slime and biofilm that are on the insides of your pipes or some of your equipment, some of that bacteria can kind of like be hiding back there. And whether the heat doesn't get there or maybe your chlorine solution doesn't get there, then you're not attacking all of that bacteria. You're not getting to everything. But again, we know exactly how temperature affects Legionella. We know that ASHRAE 188 has recommendations on how to use temperature in order to control Legionella. So now we're going to take a closer look at chlorine. And chlorine is only one of several different chemicals that are used to treat not only Legionella, but other types of bacteria within systems. Probably a lot of facilities out there are using some sort of disinfectant in order to help control Legionella and or other bacteria and pathogens, just like facilities are monitoring temperature to do the same thing. Some things to think about as far as chlorine. It's very commonly used. Point of source systems, they work regardless of temperature. So that's something to keep in mind. So depending, it doesn't matter how that temperature fluctuates within your system, the chlorine is going to be effective. It can be used in both cold water and hot water. And the other thing about disinfectants and really any other chemical out there is that most likely you're going to be using some sort of control mechanism, working with an outside consultant or company that specializes in this to make sure that everything is injected in the system the way that it's supposed to be, at the level that it's supposed to be, and that it's working properly. You don't want to go, if that chlorine or other disinfectant is too high, you can cause harm to people. If it's too low, then it's not going to work effectively. Also, the last note on that page is treated by central water source, but may also need treatment at a building or facility level. And so what that really means is that your local municipality is most likely putting chlorine or some other disinfectant in the water, but a facility should not rely upon that. There's a couple reasons. So you don't know, that facility isn't going to know what level of disinfectant they're putting into that system. They're not going to know usually if that level has been changed for some reason. The other thing is that any disinfectant, when you put it into a system, it's going to dissipate over time. So the farther that water from the municipality has to travel in order to get to your facility, the most likely that chemical, chlorine or otherwise, is going to have dissipated as it traveled. So you can't rely on your municipality to put that disinfectant in and to think that you're good to go. That's just not a good guideline to go by. You also don't know possibly if there's been water breaks, cutoffs in supply, et cetera. And so you need to be aware of that there are a lot of different things out there that could affect the level of concentration supplied by a municipality. Some things about chlorine. So chlorine is added at the building. It has to be monitored. Again, if you have too much chlorine in that system, it's going to be harmful. If you have too little, it's not going to be effective. Most chlorine injection systems, they're automated, but there needs to be human oversight, of course. And then just in the case that we were talking about heating the water up to do a super flush, you can do the same thing with chlorine. So it's called a hyper shock usually. But again, so if you have, usually in a state of emergency, you have an outbreak, you need to quickly go in and try to kill that bacteria, especially if you don't know the source of that outbreak. You can go in, up that chlorine level, do a super flush, and to kill all that bacteria in there. Again, this is not something that you would do on a normal basis, just like heating of the water. There are several things that you need to do in order to make sure that people are not harmed by that high level of chlorine. It can also cause a lot of damage to pipes, produce pinhole leaks over time, and to also your equipment. And also heating up that water can have those types of effects too. One thing that's good about chlorine is it does maintain a residual. So even though it's going to dissipate over time, and the farther it has to travel, the more it's going to dissipate, it does maintain some sort of residual even as it dissipates throughout that facility. Some of the things that I kind of talked about just a second ago that you need to consider, especially in hyperchlorination, and again, looking at the heat of the water as well. But it can be very corrosive to plumbing systems. So again, that's why, at the very beginning of the speech or the presentation, we talked about looking at the materials, like your piping materials. What are they made out of? That's why in some situations, one solution might be better than another. So you need to take a look at what materials are in your system and include those in your evaluation of what solutions to use. So some pros and cons of chlorination. I think we've covered those pretty well. It's basically easy to use. It can be automated. It does leave that residual effect. Generally low cost. A lot of times a building is going to be using chlorine or another disinfectant anyway, so you know why not incorporate that into your water management plan. But there's cons too. We know that chlorine and other disinfectants, they can affect the taste and the taste and the odor of the water, which is very important to the people who are going to be using that water. If you have inadequate amounts, it's not going to work. They also have, chlorine also has issues in penetrating biofilm, so you need to take a look at that. One of the biggest things, though, is that corrosion. It's a system leading to pinhole leaks. I've often asked infection control people what their biggest concern is about chlorine, and a lot have said, if I could take it away, I would take it away. Because if it does lead to that pinhole leak, you've got a big problem on your hands. And the other thing is it also dissipates over time. Sorry about that. Hopefully that's in the right view again. So hyperchlorination. We mentioned hyperchlorination too, and just again, it's usually easy to implement as far as changing your injection on that automated system, but it's going to leave it does leave a residual protection. You have to be well prepared if you're going to do that. You have to make sure that the system is in place so nobody comes into harm if you do hyperchlorination. I keep hitting the wrong button. I apologize, guys. Those buttons are so small. So now we're going to take a closer look at copper-silver ionization. Copper-silver ionization, it's basically, it's another alternative to help treat and reduce that risk of Legionella. It is very attractive in some ways, especially because it doesn't produce or put chemicals within that system. So that's one of the biggest things. Like chlorine treatments, it can be used in either hot or cold portions of the water system, but it doesn't have those negative side effects that that disinfectants or other chemicals may leave within that system. So where did copper-silver ionization come from? It was actually initially developed by NASA as part of their space program, and they used it to help purify the drinking water that astronauts were drinking back in the Apollo space program. So they, after that, they discovered, hey, we can use that here on Earth too. So basically how copper-silver works is that there's a plate or a rod that is placed within the water flow. The rod basically, it produces ions that go into the water. They're positively charged ions, and then they interact with the cell wall of the bacteria of the Legionella, which is negatively charged. And when those two go together, the ions bond, and it kills, basically kills the bacteria in the process. So it's a way to kill that bacteria and not put any chemicals into the water system. And so it has a lot of positives because we know that it's effective. It's been proven within the industry to be effective. Usually requires a very small amount of electricity to operate, which is nice. The rods that I mentioned, they do have to be replaced occasionally to make sure that it's effective. And doesn't fluctuate throughout the system. So we're really not spending a lot of time on copper-silver ionization, but a few things to really note. It's known to be safer than chemicals because you're not introducing those chemicals into the water system. It's fairly easy to use because it's an automated system. You can use it in both hot and cold water. It is known to be successful at distal points, so that's very important to think about, especially if you have complicated water systems. If you know you have flow or circulation issues, that's something to keep in mind. And it has been validated throughout the scientific journals, et cetera, to work. Obviously, there are some cons as well. Usually, you're going to be looking at a higher cost to purchase and could be also to maintain. It is affected by pH levels, so that's something to keep in mind if that's an issue in the area that you're in as far as your water source. You need to be aware of those pH levels. Different states have different registration requirements, so you need to take a look at that. That can be true with other chemicals as well. And some states require licensed companies to actually maintain that system, so that's something to look at too. Overall, copper silver has a very positive kind of reputation within the industry. I have heard, though, from a couple hospitals that they've noticed coloring or discoloration at some of their point-of-use outlets that could possibly be linked to copper silver, so that's something to consider. But again, you look at those pros and cons of each different solution out there, and you look at how your system is made up, and you decide which ones are the best for your facility. So UV is the last main solution we're going to look at. And in water systems, you know, especially again, going back to that chemical thing, if you don't want to use chemicals, this is another alternative for you. And kind of similar to copper silver, the water passes through a UV light. It's an inline system. And that UV, basically what it does is it disrupts the DNA within the Legionella bacteria, and it stops the bacteria from being able to grow and multiply. You'll see these systems on both the intake and the return line sometimes within the system. The effectiveness of it is proven, and we know that it disrupts that DNA, and it also doesn't put any chemicals within the system. So both important things to consider. This is kind of a partial view of what maybe a system would look like. A lot of systems, especially you'll find these a lot of times in new buildings, but you can find them in older buildings as well. These are also automated systems that you set at a certain level that it to make sure that that UV is at the right level, so it's not going to cause harm to anyone. There is basically that rod or light that's in that system. You would have to reduce that. You also have to replace that on occasion. Also have to make sure that that is clean. You don't want it producing any shadows within the system because that can negatively affect its effectiveness. They're generally, it's a less expensive solution to put in as part of your multi-barrier approach, and uses a very low level of electricity as well, because you can have a system that it's only operating when the water is flowing. So if the water isn't flowing, it automatically shuts off. So that's something to consider. Again, like many of the other solutions, even though it takes care or reduces that risk by killing or making the growth stop of Legionella at one point in the system, you have the ability for that Legionella to grow again as that water continues throughout the system. And that's what makes Legionella so hard to control, because you can take care of it at one spot within your premise plumbing system, but that doesn't mean it's not going to regrow later down the line. And again, that goes back to really knowing what your building looks like, to know how that piping system is laid out, to knowing how your flow of the water goes through. Are you using low flow point of use outlets like faucets that have great intentions to reduce the amount of water used and conserve water, which is a great thing to do, but it can have negative effects too. And one of those things that can happen is by reducing that flow of water, you increase the ability for biofilm to grow, bacteria to grow, and that includes Legionella. So again, it goes back to, and I keep saying this because I can't emphasize it enough, it goes back to knowing your building design, knowing the types of materials in that building, knowing how many dead legs you are, where they are, and knowing that circulation and flow of your water. And then looking at, okay, based on all of that information, what type of multi-barrier approach should I be putting in my system in order to reduce the amount of Legionella risk that I have in that system? So again, just a little summary of some of the highs and lows of UV. There's no harm that's put into that plumbing system. So you don't have chemicals going in that could harm a person. You don't have chemicals going in that could be corrosive to your pipes or your other equipment. It's pretty easy to use because it's automated. It's, again, highly efficient, especially in new facilities where biofilm hasn't been established yet. Very light. It's a light apparatus. It's usually, considered one of the more inexpensive, and I said inexpensive solutions. So has a lot of good reasons to put it in as part of that multi-barrier approach. One more system or solution to make that water go through. Like I said before, the light apparatus does need to be kept clean, so you have to put that on a regular maintenance schedule. You want to make sure that you know the level of scale buildup that you have in your system, and I think we'll talk about scale here in just a minute again. But if you do have scale in your system, you want to make sure that that's not basically blocking that UV light from getting to the bacteria. So you need to make sure that scale is under control. Like some of the other things, it's not going to give you distal protection. So it's going to take care of it at the point where it goes through that system, but then as it travels throughout as your water travels throughout, then you're going to have the chance of Legionella regrowing. So those are the main solutions. We're going to talk just briefly about some other solutions. And mainly these are other chemicals. So monochloramines is one of the other chemicals that is really, and especially it's growing in popularity, I would say. It's seen as safer than chlorine, but again, it's a chemical. You're going to have to look at making sure that it's in the correct levels to make sure that you're not harming a person, that it's high enough to be effective. The main thing about monochloramines, I would say, is that it's known to be slower in killing Legionella than chlorine, but it's also been known to penetrate the biofilm quicker. So it's a give and take there. Again, it goes back to those pros and cons and having that multi-barrier approach, because if you have a system that you have an issue with biofilm or scale, et cetera, then monochloramines might be an attractive way to help solve part of that problem. But you have to keep in mind that it's actually slower in killing the Legionella than the chlorine is. Chlorine dioxide is another alternative. This is another one like copper silver that you have to be aware of your pH level. It generally performs much better at higher pH levels above 7. Cold and hot water, you're good to go. Like other chemicals, it's toxic. It can be expensive. It kills Legionella, but it's known to be slow in killing Legionella. It can have side effects just like the other chemicals, but it's also known to be a little bit more effective at penetrating those biofilms like chlorine. So what I would say is you really have to look at the makeup of your water, because it's going to be different depending geographically where you're at. And you need to make sure that, you know, everything is interacting correctly. Because when you're working with chemicals, especially with more than one, you have to make sure that you're not having effects that you're not intending to have. So again, like any of these chemicals, one of the main things you have to think about are those secondary considerations. Are there unintended consequences? What is the distal disinfection? Is that how important that is to me? How effective are they at actually killing the Legionella? Are they effective but they're slow? Or are they really good at penetrating biofilm? You have to really look at all of those pros and cons. And, you know, I wish it was a simpler approach, but it's not. It's a complicated thing that you have to really look at. And that's why I keep saying, you know, it's really site-specific and depends on how your premise plumbing system is set up. So scale reduction is kind of, I would say, the last thing that we're going to look at as far as solutions. And reducing scale is not going to directly reduce the amount of Legionella that you have or the risk Legionella might have on your system. However, when you reduce scale, you're basically making whatever solutions that you have chosen to use more effective. Because scale, basically it builds up within that water piping system, and it can reduce the ability for other things to work efficiently or as intended. So as you have scale in there, bacteria can grow up. So then you have more cases of biofilm, and you have places where bacteria can hide and grow and flourish. So if you have a scale issue, you might have a increased risk of bacteria and therefore an increased risk of Legionella. So you want to make sure to make sure that you can reduce that scale if it's an issue in your system. Again, it's not going to directly affect Legionella, but it can help any solution that you have work the most effective as it can. Point of view filtration, we haven't really talked about filtration today, but in addition to point of use filtration, it should be stated you have point of entry filtration too that you can look at. The main thing about filtration, whether it's at the beginning of your system or at your point of use outlets, is it has to be at least a 0.2 micron or smaller in order to appropriately filtrate the Legionella bacteria. With point of use filtration, you'll find those at faucets and shower heads, especially maybe in patient rooms. They can be kind of costly. When you're looking at only one or two filters, it doesn't look too bad. But when you're looking at putting those filters in at, you know, at multiple patient rooms or floors or the entire facility, and then knowing that you have to replace those filters, they generally are replaced between 6 weeks and 3 to 6 months maybe. So you have to look at the cost of having to do those. One of the things that point of use filtration though does really help is it can help reduce that risk of dead legs, which other solutions that we've talked about can be ineffective at using. Sometimes you'll hear about people turning taps on after non-use, and while that's a good, there's nothing wrong with that. Turning that tap on maybe after a room has been unoccupied, it's a good practice to use. You get that water flowing, so anything that might be sitting there stagnant, you get, if you let that tap run, you have the potential of getting some of that out, so that's great. But don't think that that's doing the same thing as a filter would do. What I would say about point of use filtration and what I think is going to happen within the industry, and it's really already started, is that especially in hospitals, you're going to see point-of-use filters being used in very highly compromised areas such as your ICUs, et cetera. I think over time that's going to kind of become a norm because that's where higher risk is at as far as the patrons who are coming in and out of there. And point-of-use filters are also an excellent option to use when you do have an outbreak. You can go in there and quickly put up a solution that's going to help reduce that outbreak, and especially if you don't know the source of that outbreak, which is usually the case. It can, be very hard to find the actual place where that Legionella is coming from. So if you have an outbreak, that's one of the things that you can easily go in and do and help protect the patrons and patients within your facility. So again, filters, filtration, they definitely, I would say one of the things that I like about them the most is about the fact that they can help combat those dead lakes. They can be costly to use just because of the replacement, but they can be very effective. They are known to be effective. Again, I think what you're going to see is that they're going to become standards in those certain areas. So I mentioned that we'll go over, and I know we're close on time here, so I apologize. We'll go through this really quickly, but during this time of COVID, and I know this has been talked about a lot, but buildings have sat empty. So what happens when buildings sit empty? If the water is not circulating, that water in the piping system becomes stagnant. You have an increase for biofilm risk. So then everything starts growing. It's kind of like a party's going on in there, and all this bacteria keeps growing. You can have metals leaching, which can cause increased corrosion. And obviously, this also increases the risk of Legionella growing within your system. So there's a few steps that you need to take. And we're not going to go into detail of this. I will tell you, you can go online to WATS.com and you can find some other sources for this. But there's some initial steps. You need to map out your system. You need to set up a flushing regime. You need to monitor and test. We recommend you go through a RID process, which is recommission, inspect, and disinfect. And then you need to make sure that you're maintaining that system. And these are all steps to use to reopen that building after it's been closed down or the water hasn't been moving. Those initial steps include training your staff, making sure that they have the right protection. You want to make sure that you're documenting everything that you're doing. You might consider bringing a consultant or a water quality expert in to help you through this process, and or working with a Legionella testing facility. You need to look at what's been happening with your local utility. Have there been supply disruptions? Anything like that? Has that disinfectant level changed? And you need to really, the biggest thing to start out with after kind of these initial getting ready steps is to map out your plumbing system if you have not already. If you have your water management program in place, you should already have that map. But if you don't, you need to make one now. What a lot of facilities are doing as extra precaution is they're doing what's called a flushing protocol. And that's really to get that water moving again, to make sure that that stagnant water gets flushed out. And hopefully some of that bacteria that's been built up in there will get flushed out too. So really the main things to think about, the sooner you start flushing, the better. Flush now and frequently, even if you don't know when you're reopening that building. The earlier you flush, the quicker you're going to see good results. Most people, what they're doing are kind of an initial flush, and then they create a plan for sequence flushing. They're going to clean your fixtures and your equipment. You want to test and monitor, and then you might set up additional flushing going forward, depending on what your testing and monitoring results come back as. And this is just kind of a closer look at that flushing protocol that you need to look at. And you need to look at that entire system from your water utility to your maintenance room, through your premise plumbing, and to your point of use outlets. You want to start from the source and go to the farthest distant outlet. Throughout, you want to test the water quality, and you don't want to just test at one point. You want to test close to the source, and you want to test far away from the source, because then you know if you have discrepancies what you need to do about it. You want to make sure that you include all of those point of use and point of entry outlets. A few minor, or not minor things, but a few things just to point out. During that flushing regime, you need to make sure that you have all your valves open. It's recommended to remove those aerators if you have them. If you are keeping those aerators, make sure that they're clean. Make sure that all of your outlets are disinfected and sterilized. Might be a good time to replace outlets. And when your flushing is complete, make sure that your valves are adjusted back to a normal position. This is just kind of a recap. Again, part of that testing or monitoring should be testing your point of use taps. And there are recommendations on how frequently to do this, but really you have to look at your system and decide what is best for your system and your facility. You need to make sure that you bring that hot water system back up before reopening your building in order to make sure that it's come back up to the point where Legionella should have died. And then you want to test and monitor. You should be doing that before your flushing protocol begins, during the flushing protocol, and then ongoing. And again, if you already have that water management program in place, you really should already be doing this. If not, I would tell you to start doing it now. The only way you know if you have an issue is if you test and find out if you have an issue or not. And it's much better to be proactive than reactive. The recommission, inspect, and disinfect. This is something that we've coined at Watts, and really kind of like when you open a building, you go through and you make sure that everything is working properly according to the manufacturer guidelines. You make sure everything's clean and disinfected. That's what you need to do in this situation too. Treat it like a new building, all of your equipment. And then, of course, maintain your system. And this really goes back to that water management program. If you have that set up, then follow it. If you don't have it set up, create a water management plan and begin using that to help maintain your system and to make sure that the water is as healthy as possible. So that concludes today's presentation. I apologize. I know I've gone over a few minutes. Just as closing remarks, it really goes back to knowing your water system, knowing how complicated it is, know what issues you have, what areas of risk you have, such as dead legs, your flow, your circulation, the types of materials you have, and then looking at a multi-barrier approach that's appropriate for your facility. And that should be looked at as an approach from point of entry to point of use. And, you know, also consider, we've been talking about Legionella today. There are a lot of other waterborne and pathogens that we need to take a look at. And that's, again, why you need to look at how things interact as you choose those solutions that you use. I do have a summary table of pros and cons that we can give to you if you would like. So just to let you know there. I'm not going to repeat those objectives. The last thing I would leave you with is that if you have not already signed up, we've just started a program called Watts Healthcare Live. It is a 6-week program every Tuesday starting at 10 a.m. Eastern, going for about an hour, hour and a half. We have a industry expert speaking and a panel discussion, and it's all around keeping systems within healthcare facilities safe, whether we're talking about Legionella or other design issues. So I would invite you to go to watts.com. You can sign up there, and you can attend as many or as few of those sessions as you'd like. And that concludes the presentation today.
Okay, thank you, Jana. We did have quite a bit of questions come through here, so I appreciate you guys holding on. Before we get to those, I just want to mention quickly two of our digital tools we offer our engineering specifier audience, you guys. We have Selexa, which is our online configurator that generates your precise optimal system configurations. So this tool really helps you accelerate your sizing, configuration, and selection process for mixing valve systems, ACVs, and spin melting systems. I also want to mention Spec Hub. So Spec Hub is our project specification tool where you're able to quickly spec code compliant plumbing, flow control, water quality, and drainage products all in one place. So you're going to save time researching Watts products as they already have all the product data in there. And then when you're done putting together your project or just a quick spec, Spec Hub will automatically generate all the documentation you need, like submittals, schedules, long and short specs, and BIM files as well. So I just want to mention that we did have someone raise their hand here, and I'm going to unmute your line. Sorry if I mispronounced your name. Daljit, I'm going to unmute your line. You had a question?
Yes, that's my name. First of all, I would like to thank you very much. That was a really great presentation. I really enjoyed listening to it, and I certainly would like to get a copy of that. Thanks very much again. And I guess my question was related to water management program. I was a little bit confused. Is this a program that's after the fact when a new building is designed, or is this a coordination effort between mechanical plumbing engineers during design stage and then to incorporate this water management program for the facility? How does this work?
Sure, that's a great question. So the facility is who is in charge of making that water management program. Certainly you could work with an outside MEP person to help, create that plan, but it's the facility's responsibility to create that plan and work that plan. It should be, really any facility should have one. It's very good practice to do so. Whether you're a new building or you're an existing building and you haven't had one in the past, you should create one. There's a great example. The CDC gives a great example of kind of a framework for a water management program. So that's a good source for you to go look at CDC and just, you can probably just Google CDC and water management plan, and you'll find there's a template or a kind of an outline for it. But it's the facility's responsibility to do that. And like I said, that facility makes up an internal team. It's usually someone from facility management, your director of engineering, your director of facilities, infection control, maybe a safety professional within the system.
Right.
But it's their responsibility to create and maintain that water management plan.
Got you.
Excellent. Thank you. We did have
I could see a couple of questions. Oh, I'm sorry. Go ahead, Greg.
Did you want to address some questions that you're seeing?
You're kind of cutting out on me, so I'm going to quickly answer. I see two things in the chat. Can it be transmitted patient to patient? No. That's an excellent question, but no, it cannot be transferred person to person. The only way you can get Legionnaires is to basically inhale it or aspirate it. So the two best scenarios or examples is like you're in a hot shower and you're breathing in that mist. That is one way to get it. That could come from a shower. It could come from a decorative fountain, etc. The other way is aspiration. The best example I can give of that is a lot of key patients in hospitals are put on an ice-only diet. And imagine you're chomping on ice, you get choked up. All of us have done that before. And that water goes down the wrong pipe, and you aspirate it. And that can be a source of how you would get it. But only from aspiration or inhalation, and no for patient to patient. And then the other thing I see is the standard chlorine treatment. So the typical recommended levels are 0.5 to 2 milligrams per liter for daily use. So that's kind of the overall guidelines, but I would definitely check that out at a local level.
Jana, we had someone else raise their hand, so I want to get to them. So Christoph, if you want to ask your question, I'm going to unmute your line.
All right, I think hopefully you can hear me.
Yep.
Hey, Jana, as always, great presentation. Always love you. Hey, so more comments. Just wanted to add to some of the stuff you said. Actually, really interesting study from, I think it was 2018, Tufts University, that found that up to 30% of all healthcare-acquired infection costs came from water. You know, when you compare that to surface or air or person-to-person or any of the other modalities, you know, the stuff in our water that a healthcare-acquired infection can come from, it's probably some of the worst stuff out there. The other thing I wanted to mention was, let's see here, that the water temperatures, we got to be, it's definitely a risk reduction methodology, and it's definitely worth looking at and engineers evaluating. Just keep in mind that when we talk about full-on prevention and control, it's again more of a risk reduction. There was one study that came out that showed that in a plumbing hospital system, that after an hour at 106 degrees Fahrenheit, about 10% of the bacteria still survive in the biofilm. The conditions which we all refer to those charts, which are good, are for planktonic, that is free-floating bacteria, but sessile bacteria, that is bacteria in the biofilm. The biofilm can act as an insulator. Although there is some, I think there's still some discussion going on whether the sessile, that is the bacteria in the biofilm, pose as much of a threat as the planktonic one. So that's one I'm still kind of digging into. The copper sylvanization, I'd be interested in, you had mentioned 8.5 pH being an issue. I'm familiar with pHs above 10 causing an issue with CSI. I could be wrong. You know, I'd be really interested in knowing, and that's mostly due, in my understanding, is due to at higher pH levels, metallics become less soluble in the water. That is, they don't dissolve as readily, which is part of the reason why municipalities, when they start adding corrosion inhibitors, they start increasing the pH, which actually also decreases the effectiveness of things like chlorine. And then finally, just to add to, you know, sort of things to be mindful of for engineers, the oxidizing disinfectants, things like chlorine or chloramine, not CSI, since that's a metallic disinfectant, but again, probably more commonly used ones, chlorine or chloramines, and chlorine dioxide. Code requires that ventilation be provided with both a low and high wall return, or I should say exhaust. And that for those materials, since they're considered hazardous, OSHA ANSI requires emergency shower and eye wash within 10 seconds of the storage, and that space has to be negatively pressurized compared to adjacent spaces. So great job again, Jenna. I always love these presentations. Thanks for what you put together.
Thanks, Christoph. I think actually kind of what Christoph was saying there is a good example and maybe a way to kind of close out today's discussion, because I know we're way over time. Premise plumbing systems are complicated. The way to reduce the risk in of Legionella, it's not a straightforward thing. It can be complicated and complex. Everything interacts and can cause different solutions to be more or less effective. The water quality and makeup and geographical areas can vary vastly, and that affects all of these things as well. So I would encourage each of you and myself as well. We have to continue researching, testing, et cetera, to continually improve upon our ability to reduce the risk of Legionella. So I greatly appreciate each of you for taking the time today.
Jana, can you advance it to the next slide? I just want to, we do have a lot of chat questions coming in here that I want to get to, and a lot of you guys are still on, so that's great to see, and we'll do our best to walk through them. So the first one here, well, first of all, we have our email addresses on the screen here if we don't get to your question, but we'll do our best. First one I'll read off here. Any idea how many people the 400% increase in infections represents?
I could not hear you, Greg.
Sorry, can you hear me now?
Yeah, you're going in and out on me for some reason.
I'll say the question again. Any idea how many people the 400% increase in infections represents?
I do not know that off the top of my head. I apologize, but if you Google it, it will easily come up.
If Legionella is from inhaling, aspirating, and a patient isn't at risk from drinking water with it, what is the rationale for ice machines?
It goes back to that chomping on ice. So if the Legionella bacteria is growing in that ice machine and within the water that makes up that ice, and somebody is chomping on that ice and gets choked up, that's how you could get Legionnaire's disease from ice.
Okay, and would you consider a branch pipe to a lavatory sink a dead leg? There may be some time before a faucet is open, say 24 hours, creating a flow in that branch pipe.
There's an exact definition of a dead leg, which I'm trying to remember how many inches it is, but there isn't an exact definition. The main thing I would say, and here's really the overall concern, is anywhere within a system where water can sit and get stagnant is what you need to be concerned about. So whether that's an outlet that is infrequently used, or if it's an actual defined dead leg, those are going to be high-risk areas.
Okay, and why doesn't Legionella become resistant to hotter water environments over time, the way that bacteria becomes immune to antibiotics?
That's an excellent question. I do not have a good answer for that one. I'll just tell you up front. Legionella, a lot of the solutions that we have for it, it kills it at the point of time, but then it can regrow. And it's really the environment that makes it able to regrow. So when that water becomes stagnant, when it's the temperature gets in those growth zones, when there's biofilm present, all of those things, that environment creates a place for it to grow and proliferate.
Okay. How would you pass superheated water throughout, say, a hospital if all labs and sinks are point-of-use TMVs?
Well, anytime that you have to, if you're looking at doing a super flush, you have to be very precautious. You have to make sure that those outlets are not available for people to use. You might have to go outlet to outlet to turn those off. It can be very time consuming. So there's a lot of negatives about that, but it is a tool that you can have in your toolkit to help you, especially in case of emergency.
Okay, at what point does hyper-chlorination affect pipe materials like copper?
So there are studies out there that show how different disinfectants can have different effects on different types of piping materials. And I can probably send you some of those studies if you would like. But definitely chemicals can have different effects on different types of materials. So it's important to know that when you're choosing these solutions. Any of them, though, can have the ability to create corrosion and the possibility of pinhole leaks.
Is the EVA, sorry, I'm going to mispronounce this, probably Avapco Pulse Pure a copper silver solution? Avapco?
I'm not for sure I followed you there, Greg. And I'm not seeing that. Okay,
let me go to the next one here. What type of flows is the UV light treatment capable of handling?
They're different per product. So you would really want to take a look at your manufacturer, what you're looking at. But there are different sizes of rods, different sizes of lights, I should say, that are capable of different flow rates.
What is the life of UV light when operating a system?
Again, that's going to vary from manufacturer to manufacturer, but and don't quote me on this, but I think most off you're going to look at maybe replacing that light every year or so. But again, it's going to vary from manufacturer to manufacturer and how often that water is flowing, so how often that light is on. Some products have the ability for that light to go automatically on and off, so obviously that's going to increase the lifetime of that light. Other products do not.
For the copper-silver ionization, how often and what kind of cost of the replacement rods are you talking about?
You know, I'm going to say I do not know enough about those specific things to give you an answer. I would be glad to do some research and provide you with that information later, though, if I can get your contact information.
What is best to deal with biofilm buildup?
You know, biofilm is a complicated solution or a complicated issue, and I'm certainly not a microbiologist. So I'll tell you my layman response. So the best thing to reduce biofilm and bacteria is to keep your water flow going, to keep the circulation of the water going. Anytime that water flow is slow or stagnant creates an environment in which that biofilm will proliferate. So I would say the standard basic thing that you can do is make sure that water keeps flowing.
Okay, great. What if you have also a high pressure system, say a high rise? Can you use the light tube on high pressure?
I think you're referring to the UV system. And again, I think, yes, that's possible, but you would need to look at those flow rates and make sure that the manufacturer guidelines allow for it.
For the copper, you may have already answered this by your radar. For the copper-silver solution and the UV solution, does this equipment vary in size based on the flow of the system? How are they sized based on flow or pipe diameter?
So, yeah, and I don't have the details on that. That's something that we could take offline. But yes, there are different sizes of those systems that, depending on pipe size, flow, a lot of it's flow rate, that you would choose what size, what equipment that you would use. You might also have more than one piece of equipment in, depending on flow rates or locations and how that premise plumbing system is designed.
Is there a minimum or effective flow rate for a good flushing?
Say that again.
Is there a minimum or effective flow rate for a good flushing?
I'm sure that you can go out there and find effective flow rates that would be recommended. I will say that I do not know that off the top of my head. I'm sure somebody that is on the engineering side of things could probably quickly tell you that. But it's going to be based on size and the circulation and design of that premise plumbing system.
Okay. Is it not recommended to turn down your hot water heater when on vacation? Will hot flush after 2 weeks no flow be sufficient?
That's a question that I'm not presented with often, especially it sounds like you're talking more about a residential situation. I would say, cases of Legionella within single residence, it's one of those things that is talked about quite a bit in the industry because one, you don't hear about it often, but the opportunity for Legionella to grow within a house is definitely there. I would say anytime, not dependent on the building type. If your water is going to be sitting there for an amount of time, or you've turned down the heat for some reason, I think it would be a smart practice to go in and open up your outlets and let them flow for a while, get it back up to normal operation, just as a precaution.
Okay, for reopening buildings, what if we're talking about a building that was only at, say, half full or less instead of a complete normal occupancy? Do the steps in flushing come into play in those instances?
So I would say, every building, that plan for flushing is going to be a little bit different. And I'm sorry I keep saying that, but it's just a fact. So whether it's half open or completely shut down, it depends, how is that system operating if it's half open? Are there portions or floors or certain departments that are all in the same area that are completely closed off? Anytime that water is not flowing, it would be smart for that facility team to take a look at, okay, how can we get that portion or the entire system back up to normal operation? And how do we do that before we expose people to it? So I would say it makes sense to look at some sort of flushing protocol, no matter if it's half open or completely open. But it's something that facility team and owners would have to look at.
Okay, when you mentioned water fountains, are you referring to a drinking fountain, a decorative fountain, or both? And do these present similar issues regarding Legionella?
So absolutely, it could be both. Drinking fountains, water fountains. As far as drinking fountains, that's going to be the same risk as, a faucet, a sink faucet. Could absolutely have Legionella growing in it. Decorative fountains are definitely a risk. That's why you do not see any at hospitals anymore. The one thing that's kind of interesting about decorative fountains, a lot of them have lights in them to light up at night, which increases the temperature of that water, which can create an environment that is more opportunistic for Legionella to grow.
Okay, how does this affect, this is referring way back in your presentation, I believe, how does this affect a condensing boiler, a heat and hot water system, or a water heat pump condenser water system where temperatures can reside in the 100 to 130 Fahrenheit range? Accepting these are closed loop, is there a risk that needs to be considered?
So I think the simple answer to that is any time that water can be in that temperature zone in which is conducive for Legionella, then you need to take a look at how to address that, whether that's through mixing valves, visual mixing valves, et cetera, or how, making sure that water is flowing correctly. But anytime that water is in the range where it can grow, it's something that you should be taking a look at. No matter where it is.
Sorry.
No matter where that location is.
Okay, very good. Next question here. Do you recommend the inclusion of a chemical feeder in a DHW system design?
I think that's dependent upon the facility, but it would be very common to have both. That goes back to that multi-barrier approach. It would be very common to have mixing stations and chemicals within a facility, both programmed to help reduce that risk of Legionella. So to me, the bigger and the more barriers you have, the less likely you're going to have a problem. So if you're able to put multi-barriers, multi-solutions in a system, I think that's a good thing. Okay,
are there increased risks of Legionella in restricted use DHW potable, sorry, the question is getting cut off here. Let me repeat that. Are there increased risks of Legionella in restricted use DHW potable water systems in a COVID-19 environment?
I think when you're talking about COVID, no matter what type of system, what you're looking at, the main thing is, has the flow been reduced? Has it become stagnant? No matter what type of system that you're looking at, that's what it goes back to. So if the answer is that flow has been reduced over a period of time or it's been completely shut off, then yes, you have a situation in which Legionella or any other type of bacteria could be growing at a more proliferated rate.
In copper-silver ionization, where do the ions go after bonding to the bacteria?
They get flushed out through the system. That is not an issue that you need to be concerned about. They go out through the system.
Should cold water be circulated similar to hot water?
Yes.
Are there any human health effects from consumption of copper or silver ions or byproducts?
Not that I am aware of.
Is there a recommended minimum velocity? I don't know if that's a continuation of a question. How does the SmartStream UVC address contact time for inactivation?
I'm not 100% sure that I understand that question. If it's contact time between the UV and the pathogen, then there's certainly, it has to be in contact for a certain amount of time. As with any type of UV system, I would have to go back and take a closer look at what those contact times are. I apologize, I don't know those off the top of my head.
Okay, next question. Is there a safe and effective way to self-test the water for Legionella in a building that has not been in use after you have flushed the building?
Sure. So what I would always recommend is working with a licensed facility that specializes in Legionella testing. By doing that, you are given the ability to get the most accurate results, and they can also guide you through how to do that, where within the system you should be testing, how often you should be testing, and they'll also give you very good guidelines and protocols on how to take that sample effectively and get it to them effectively so you get accurate results. But I would always recommend you, there are several different facilities or organizations out there that are licensed specifically to test Legionella, and that's who I would go to.
Are on-demand hot water heaters safer for Legionella than tank heaters?
I'm not an expert in that field, so I'm going to bow out of that one. I know that there are some other people on this call right now that could answer that very effectively. So if you want to do so, raise your hand and we'll let you do that. Again, it goes back to how long is that water sitting there. So if you don't have water sitting there and not circulating, then overall your risk is going to be lower. If it is sitting there, your risk is going to be higher. And I know that that can vary greatly within, the different types of heaters and boiler systems that are out there.
Okay, next question here. Is there a danger of point contamination at the mixing valves with the introduction of cold water with dormant pathogens to temper the high temperature hot water?
Not for sure if this is going to answer that question or not, but if you're talking about the temperature fluctuations, so anytime that temperature is in the range, no matter where it is, within the system or at the mixing valve or at point of entry, point of use, doesn't matter. anytime that's in the range for growth, then there's going to be an increased risk. I'm not for sure if that answers your question, though, so I apologize.
Are bottle fillers more safe than water fountains?
That's a question I've never gotten before. I would have to think about that for a bit. And I would tell you for sure that I don't know the mechanics of a water filler or how they differ from a fountain. But they would have the same underlying risks as far as how they're made up, how the water flows through, et cetera, but I technically don't know. I have to say, I'm very impressed with all the questions today.
I am too. This is an unbelievable response.
These are the most questions I've ever had.
And there's still a lot of people hanging on, and I believe we've come to the end of these questions. I know a lot of you requested, a copy of the presentation and a copy of the charts that Jana was talking about earlier. So we have your names here, and we will send you those documents. I think that is it for the questions. So Jana, if you had anything else, I can close it out.
I just want to say, thank you for joining us today. I know, everyone's time is precious, and I know we get kind of tired of the webinars as well at this time in our life. So I appreciate you joining us. If I didn't answer your question today, or if I didn't answer it effectively, feel free to reach out to me via my email, and I will do the best to get you an answer. If I don't know the answer, I'll do the research and get it to you, or get you to the right person to answer that. So.
Excellent. Thank you, Jana, and everyone who joined us today. Like Jana said, our emails are on the board here. Also, feel free to reach out to us on LinkedIn, connect with us there. Also, in the next few days, you will be receiving a follow-up email with the links to the recording of this webinar, along with the quiz you can share with your colleagues, and they can take it to earn the 0.1 SBC credit if they missed today's webinar. There will also be a link to our healthcare symposium event, which will be every Tuesday at 10 a.m. Eastern time from now until December 15th, except on the week of Thanksgiving. There will also be another link there if you want to reach out to your Watts rep if you had any other questions as well. So thank you all again for joining today and hanging on way over our time limit, but we appreciate it. And that's it. So enjoy the rest of your week. Thank you.